Assalamualaikum. Um, In this video, we will discuss a simple problem from the book of Engineering Dynamics written by Mariam, 6th edition. The simple problem is 2 by 1. It's regarding our rectilinear motion, which I have explained the basics in my another video. So if you overview the statement, there are different segments that we need to find. First thing is that a motion equation is given to us, which was a function of time, and then we have to find the time when velocity approaches to 72 meter per second. So we will proceed how we can solve this issue. What we have an equation, and we know that from our previous video that displacement, if taken the derivative of displacement with respect to time, we will have velocity. So by taking the derivative of this equation, we know that in derivative the power multiplied with the coefficient and 1 is subtracted from the power. So the 2t cube will be converted into 6t square, whereas 24t will be left as 24 and 6 is constant, which is in derivative becomes 0, and our velocity equation will be 6t square minus 24. So it is given to us that velocity should be 72 and find the time. So by placing the value of velocity in the equation we have calculated, we have time as 4 seconds. When you solve the equation, you have two values of time, plus and minus. And we always know that time will be only in positive direction. Time cannot be in negative. So our answer will be positive 4 seconds. The second part, we have to find the acceleration when velocity reaches to 30 meter per second. So we know that the derivative of velocity with respect to time is acceleration. By following the basic concept of derivatives, we have equation as 12t. Now the problem here is that acceleration is again the function of time, and we don't have the time at which we have to find the acceleration, but we have the velocity. So first we use the concept of velocity to find the time, as we have done in our last practice, last slide. So by having the velocity equation, equating the velocity equation to 30, the time becomes 3 seconds, and by placing this time in acceleration, we have the value of acceleration is 36 meter per second square. You should be very careful with the units. You should be very clear about the unit of acceleration, velocity, and time, when the basic units are meter and second, or the other ways that there may be in feet or uh, hours or second also, or it may be in some other kilometers per hour. Segment, that net displacement from time 1 to time 4 second is required. Now we know that the displacement is the uh, length of shortest path from point 1 to point 2. So it's very simple that we have to locate the position of particle, because it is a rectilinear motion in a line at time 1, and when we have to find the position at time 4, and by adding these two positions, either they are positive values or negative values, we have to add them, we will have the net displacement in the set time. This is very simple. It is 54, just placing the values. Added another aspect in this, because distance is also sometimes important while you are moving or designing some machine element which is moving in a line. No doubt the position is important design factor, that at this time the position should be there and at this time the position should be there. It's fine. But when we are designing or studying the life of an element and study the energy analysis, we should know the length of the path it travels from one point to other point. Let's say we are interested that at time 2 seconds the particle should be at such place, and particle at 3 the particle should be at this place. And it is not very simple that the particle stop and move back. Obviously it is moving with some velocity, and it needs some distance and some speed reduction. So the travel time is also very important. The travel distance is also very important in order to calculate the energy, in order to calculate the life, because the longer the path of the length the particle travel, the shorter will be its life. So keeping in view this important aspect, I have added in the same case how to find the length of the path traveled by the particle from 1 second to 4 seconds, which is distance. It is not displacement. If you have any confusion, you can watch my other video regarding the basic of kinematics, where I have clearly explained the difference between distance and displacement. So in order to find this, we can go and we can use, but I recommend that you use Excel, and this is a format of Excel where we can have time, and then we can write the equation for displacement as I have mentioned in the column here. From this point you can easily find the location of how to write the equation. Multiplication purpose we use steric, for power purpose we use this cap, and minus plus is very simple, and then we have to write the cell address and then drag them. We can have the location or this. The second way is that we can use the equation, and from the equation we can find all these four values. So what is next, that we should draw a graph by using the data instead to clearly visualize what's happening and how the particle motion is changing. So this is graph is only showing the displacement position with respect to time. It is a curve. It doesn't mean the motion is not rectilinear motion. The motion is rectilinear, but this graph shows us the relationship of time with respect to displacement. Previously, we have discussed that when we have to find the some aspect velocity and other aspect, we draw the diagram between displacement and time, velocity and time, acceleration and time, and so on. Many options we can draw and conclude the things. So how we interpret this graph and this value? Now, in our given case, at time 1 second, the particle position is 16 meter, and at time 2, it was 26 meter minus. So it means in from the time 1 to 2 second, the particle move from minus 16 to minus 26. Now the length of the path it travel is 10 meter. There is no concern of negative sign here, it should be minus s, no, because it's the length of the part is the same way that you are moving on a road and you observe your speedometer and there is a distance mentioned. You go in one direction, then come back and reaches to your initial position. But doing this, there is a distance travel, and this distance is always positive. So from minus 16 to minus 26, you have traveled 10-meter distance, and then the next, that at time 3 second, it reaches at point minus 12. It means it comes back. So the travel distance was minus 26 to minus 12, which was 14 meter. And then we have at 4 is 38 meter positive direction. And then if you calculate the distance, which was 50. So the length of the distance traveled from 1 to 2 seconds was 10, 2 to 3 14, and 3 to 4 50. The total distance will be 74 meters. Now it seems very good, very fine. But here is one thing, is that the particle stop moving at some specific time, because it means it velocity was reduced to zero and then it moves in opposite direction. The only error in this calculation is that we should be very careful. We have to find first the time where the particle changes its direction. Like you see, at time 2 second it was at minus 26, and at time 3 it was minus 12. It means in 2 to 3 second, maybe in 2.1 second or 2.2 second or 2.3 second, it's this continuous motion and stop at one point and then comes back. So the only thing is that we have to very sure where the particle is stopped in order to find the exact distance, which I will display in my next coming slide. To overcome the issue, that we should know at what time the particle stops so that we can exactly find the distance. Now reconsider my words, that the particle should stop means the velocity should be zero. By taking this concept, by equating the equation of velocity with zero, the time is 2 seconds. Now it is the whole number within our range. It means our calculation was fine. But what if it was 2.1 or 2.2 or 2.3 second? Then we have to find the distance up to 2.3 second, then 2.3 to 3 second. We have to split like this so that we can have the exact distance traveled by the particle. Thank you very much. If you like my video, kindly subscribe and share this video. Thank you very much.